Okay, it's giving us the results of a survey. Some of the tables already filled in, and then some of it we have to do on our own. So 5 girls preferred track. So girls, track, 5. 4 boys preferred track. So 4 boys in the track column. 6 boys preferred basketball. That was already there. 15 girls preferred soccer. That was already there. 25 students preferred soccer. So that's 25 students overall. We already have 15. How much is here? 10. That gives us our 25 total. And a total of 50 students participated in the survey. So if this needs to be a 50 overall, what's this? 30. And then it's sort of a domino effect. If these needed to add up to 30, we already have 20 females. We need 10 more. And our track column, 5 plus 4 is 9. And so all of that should work out. 16 plus 25 plus 9 gives you 50. So we complete the table. That's probably good for a point. What is the probability that a student preferred basketball given that the student was a girl? Okay? A given probability immediately restricts which row or column we're looking at. Hold on. So, chance. Read that again and tell me which row or column we should only be focused on. Correct. Given that the student was a female, so we are only focusing on the female column. So out of those females, of which there are 30, out of those 30, what is the probability that it is someone who preferred basketball? And what would that number be, Riley? 10. Perfect. So to write in notation form, because some of us struggle with this, and you have to say what you're calculating, especially as this is going to lead into our independent events question. This is the probability that we preferred basketball given that it was a girl. Or maybe I'll use female, because I'll use female and male so that there's no overlap in letters. Otherwise, B might mean boy or basketball. So, and if you're not even sure there, you go ahead and write out the whole thing. Probability of basketball given a girl. Okay? No one's telling you have to use it one letter. You can write out the whole thing. Now, are being female and preferring soccer independent events? So, what do we have to calculate? There's 2 calculations that have to be made if our 2 variables are female and soccer. What are they, Morgan? Correct. Being a female, given that you prefer soccer, right? Okay? Those are your 2 probabilities that you know. This is what some people are doing, and I'm telling you this is going to be on your Regents, and you cannot do this. People are computing the probability of being female, and they're computing the probability of liking soccer. That is not how independent events work. You have to do one on its own, and then the second one has to be that same probability, but given the other condition. So the probability of being female overall, we have 30 females out of 50 people. Now we're back to a given probability. So Molly, let me ask you, if we're looking for the probability of being female given that you prefer soccer, which row or column am I only paying attention to? The soccer column. Very good. So out of those 25, given that they have to play soccer, so out of those 25, what's the probability, or how many of them are female? 15. This one's going to give us 0.6. 15 divided by 25 gives us 0.6. So are they independent or not independent? Independent. That's one of the rare times that that's ever happened, huh? That's it. Your justification is in your work. If they're equal, it's independent. And why is that? Because your probability of being female did not change at all if you like soccer, right? If your probability of being a female was 60%, and then your probability of female, given that you like soccer, skyrocketed to 95%, then we would think, okay, there's some relationship there, that for some reason girls are more likely to like soccer, right? But when no change was made, and your probability of being female is exactly the same, then there is probably no correlation between whether or not you're a girl and whether or not you pick soccer, okay? I've never seen a question where you have to explain in a sentence form. It's always justify, but do make sure you answer. And, I mean, I guess technically the answer is yes, right? Are being female and preferring soccer independent events? Yes. Okay? And then 36. So on 36, and your flashcard has some info on this. What is the y-intercept? Your y-intercept comes from setting what equal to what?
Don't we combine those terms?
X equal to 0, right? Nope, I'm just going to set x equal to 0. So my y-intercept is going to be 0 plus 2 times 0 minus 1 times 0 minus 5. That's 2 times negative 1 times negative 5. That's 2 times 5, which is 10. My y-intercept is 10. What are the zeros? Your zeros come from your factors, right? And since this is already factored, life is pretty good. If the factor is x plus 2, what's the root? Negative 2. If it's x minus 1, the root is 1. And if it's x minus 5, the root is 5. Is this function increasing or decreasing over the interval from negative 3 to negative 1? I recommend we type it into our calculator. So I'm going to type in x plus 2, x minus 1, and x minus 5. And I'm going to take a look at this graph, specifically from negative 3 to negative 1 on my x-axis. So when I go to my window, they want it from negative 3 to negative 1. And I'll keep my y's at negative 10 to 10. If it's not enough, I'll change it. Is that increasing or decreasing? Increasing. And then how many relative extrema does the function have? Now I'm going to open up my window. I'm talking overall here. So if I go zoom 6 and change this to negative 10 to 10, okay, you can't quite see the whole graph. I may want to open it up just a little bit more, looking up and looking down. So I would open it up, but I'm going to have a max there, and I'm going to have a min there. So there are two relative extrema. Does that make sense? Okay. So your homework tonight is test 4, which I posted online. The first section of numbers. Again, if you want those numbers, I'll put them right here. So test number 4. Another quiz tomorrow.